There's a feature that's part of procedural terrains that's somewhat overlooked, and it can be incredibly important for controlling procedural terrains and the materials, and also what happens to a terrain if you are to convert it from a procedural over to a height field or standard terrain. So we're going to go ahead and add a procedural terrain to the scene and just have a blank scene. Go ahead and lift it up a little bit above the ground. Now if we open up the terrain editor, we can double click on it to open it, right click or edit object also to open it. Within the procedural tab of the terrain, what we're going to find is a section that is for the quality settings and a couple other things for the procedural terrain. What we're going to be taking a look at is the force extension. Now by default, the force extension is set to basically an automatic mode. It will change relative to the output of the procedural. So if we were to randomize the terrain and change that around, we'll see the force extension kind of go up and down depending, and just bounced up to 2.5 from 2 and back down to 2, now 2.4, and it's going to be based on the output of that altitude production. Now, the benefit of this is that it allows you to basically have just about any output without any clipping occurring, cutting out the terrain and cutting out the procedural. But it does have, I think, more negative effects in the way we control materials and also conversions to height field terrains. Also, the scale of the terrain itself is modified by this and inaccurate. So I'm just going to go ahead and cancel this for now to go back to the original terrain I started with. I kind of like that one better. We're going to take a look in the side view, or the front view, and we can see a bounding box showing the outer extent of the terrain. Now it falls far below the actual altitude of the terrain. So the size output says 230 meters, but that's not actually 230 meters tall as far as the actual geometry. That is the total amount for this negative space and the above space. So that does make it difficult to judge the scale. And this extra space is also taken into account when working with material layers. And if I was to go ahead and just add another material layer, and we go into the presence tab, we have an altitude range -1 to 1. Well, the -1 will be more towards the bottom, and not actually the amount of terrain that we see. It does also affect the object parametric altitude input control within a material. We'll take a look at that in a minute. If we go back into the terrain editor and take a look at the coloration, because of the force extension, the color map for the height that really gives us a preview is more limited, and also doesn't match the function output observer if we go to edit the altitude reduction. You can right click, go to edit function, or you can control click on this to open up the function editor, and with the output observer open, we see the actual elevation being put out. If we turn on auto fit, it'll be a little bit closer, but it's still going to be off and not going to match what we have in the terrain editor. Also, when we're using the altitude brush and controlling clipping, it's not entirely accurate. So in order to fix this and give ourselves a range that's accurate, what we do is turn on the force extension and set it to 1. 1 is going to completely fix just about all the problems you're going to run into. It does need a few additional settings in some cases to correct the flattening of areas, or basically clipping, because it does modify the output that is needed and basically constrains it. So to make sure that nothing is getting cut out, all we need to do is make sure that the function and the altitude falls within a range of -1 to 3. And that's going to be our total output value before clipping occurs at the top and the bottom. Also, a cool thing about working with the force extension of 1 is once we're in the terrain editor, or within the altitude production, using the function output observer with the auto fit turned off will give us an exact representation of the terrain. Of course, in this case, I've got 0 edges turned on, so I'm just going to go ahead and turn that off. And we start to see the clipping on the bottom, and also the coloration where it just starts to get more red, orange towards the top, and it's going to look the same way within the output observer. So this gives you an exact representation of the terrain without it being variable. So all we need to do in this case is just bump it up a little bit. So I'm going to add a filter just before the altitude output and set it to offset. And we just need to offset just enough so that we're not being clipped out in the bottom. So about 0.4. And I can turn back on 0 edges if we want to have that on. And now that clipping and cutout on the bottom is gone. Another thing you'll notice is because our bounding box fits correctly all the way to the height, our actual scale output for the Z is now going to be correct. And I just want to show you the altitude control within the material. And what I'm going to do is edit the material, go to the color and alpha tab, just double click on the color map, and under rocks and grass there's just a black and white gradient, which is the first one you can load in. We're going to edit the function and connect this to the altitude input up at the top. So disconnecting from that constant node and connecting it there. Now this is actually going to be incorrect for the moment, because there is one little thing about terrains, just terrains, that have an issue with this input node. First we'll go ahead and just take a look at a render, and one thing we can do to really just take a look at the color that's being produced by this is in the material editor we can ignore the atmosphere and ignore lighting, which is just going to show us the color output. So no diffusion, no shadows or anything. So I'm just going to render to screen just really quick. We can take a look at this, and then we'll go ahead and fix the altitude output so that it works correctly within the function. So if you do want to control altitude distribution within a function, there are a few changes that need to be made. Now to make sure we're also not changing the material any further, we're going to go to the post options and make sure that auto exposure and natural film response are turned off. And this will give us the exact color output. Now it is being clipped, and it's also gray at the bottom where it should be black. So within whenever you're controlling material within a terrain, the altitude input for the object parametric mode, which basically is just the extent of the size of the terrain, so from the top to the bottom, using a value of 1 to -1. And if we go over to the scale in the function node preview, we can set the scale to 1 since I'm using a parametric material, and then we can turn off and on the automatic extension and see that it goes from 1 to -1. But it is incorrect when rendering, showing the output, and what we need to do is go to the offset, or add an offset filter and offset it by 1, and that is going to correct the altitude and display it properly. So this should be done anytime you're using that parametric input. It is locked to the size of the object, so 1 is basically always the top of the terrain, 0, or -1 is always the bottom. Now, if I was to go back in to the terrain editor, turn off the force extension, go back to the automatic, and now we take a look at this parametric altitude, it's going to be really far off. Because now there's negative space being taken into account, the offset's off even more, and it changes depending on the terrain. It's really not something that's useful if you're going to create a material that you maybe want to use over again on different terrains. Even with the parametric input, it's going to be variable, and we don't have the full range of the altitude as we should have. So bring that back down to force extension of 1, and then we can work with it properly. Now, the last benefit of this is what happens when we convert to standard terrain if we plan on using effects, or even just getting things closer to real height field or standard terrain. I'm going to go ahead and just reset the material. And first, if we take a look at just a height field terrain, we can see it starts at that green on the bottom, so it is going to start at 0, and the overall height is accurate, and it's basically generated in the same way that the force extension set to 1 under procedural terrain would be, and is completely accurate. Now, with the effects that we run on standard terrains, they start from 0 basically. If I was to start adding alluvium, add dissolval, it's dissolving from the bottom. All of the different effects are starting from 0. Now, if we were to take this procedural terrain, turn off that force extension, convert it to a standard terrain, and start trying to apply effects, it's not going to be very intense because of the range that it's starting from. In some cases, you won't be able to get really much of anything at all. So if you want a more accurate representation of that, I'm just going to cancel, go back into the procedural terrain, and keep that force extension at 1, and then convert it to a standard terrain. And now as I start to add the effects, you can see they're applied a lot stronger and more like a standard terrain or height field terrain that you create within the editor on its own before converting it over. So it will give you a lot more control over the usage of the different erosion effects if you create something as a procedural terrain first and then want to maybe apply some effects to it. And that way your range is correct starting from 0. Another nice thing about using the force extension of 1 when converting to a standard terrain is it does remove a very large box that will show up underneath the terrain if you convert it without that. So if we take a look, if I just convert a procedural terrain to a standard terrain without modifying the force extension to 1, we end up with this huge box and offset of the terrain underneath it. So we can basically remove that, and that's not going to be part of the height calculation or altitude calculation within the material.